we got to do these next. So, all right. Example 3. We need a common denominator here. So between 2, 3, and 6, what common denominator would you use? 6. And notice here you got an x squared, and you just have an x here. So that common denominator needs to be the 6x squared. So this first one here is going to need to be multiplied just by 3 on top and bottom to give you the 6. The second one is just needs a 2. Make sure when you multiply by 2 here that you put parentheses around that x plus 2 because that whole numerator has to be multiplied by 2. And then your 6x here has already got the 6, but it needs an x with it.
So it just be x over 6x squared.
Yes. So we've got 3 over 6x squared equals, if you want to, you can go ahead and distribute this 2 right here. So 2x plus 4 over 6x squared minus x over 6x squared. And once the denominators are all the same, we can multiply through by 6x, which just cancels all those denominators out. So that leaves us with just the numerators. So 3 equals 2x plus 4 minus x. This is just a simple linear equation. You just need to get the x's together, which will give you x plus 4. You'll subtract that 4. And x equals negative 1. We do always want to look back at our original problem and make sure that is not going to give us a 0 in the denominator. It will not here because 0 is the only number that would do that. That's our only excluded value. So this will be our answer. Okay. All right, here's our next one. So if you ever have any terms that do not have denominators, you want to give them a denominator because there must be a denominator there for you to do this problem. And all of those denominators have to be the same. So we've got an m minus 3 and an m plus 3. It would be nice if we could just take this like m plus 3 and turn it into an m minus 3. But to do that, we would have to do something, don't write this down because it's wrong, like subtract a 6, right? If we did that, m plus 3 minus 6 would give us m minus 3. And then we could do that. But let's think about whether or not that's a legal move. Okay? I know I can multiply on top and bottom, but if I have something like 30, no, let's not do 30, let's just do 3/4. 3/4. If I subtract the number from the top and subtract that same number from the bottom, does it give me an equivalent fraction? Is that the same? 3/4 is not the same as 2/3. So we cannot do this. So you cannot add or subtract to the top and bottom of a fraction. So we cannot do what I've just tried to do here. We can only multiply. Top and bottom. Technically, you can divide, but we're not going to run into needing to do that. So we're only going to be able to multiply, which means my common denominator, my least common denominator, is going to have to be m plus 3 times m minus 3. It's going to have to be those two things multiplied together. So this first fraction doesn't have either one of those in the denominator. We would have to multiply by m plus 3 and m minus 3 in the top and the bottom of that fraction. Okay? If I look at the second fraction, which one am I missing? The plus 3. So I'm going to multiply the bottom by m plus 3 and the top by m plus 3. And then for the last fraction, I've already got the m plus 3. I need the m minus 3 here. So, is it okay with you guys? So, I can see I've got m plus 3, m minus 3, m plus 3, m minus 3, m plus 3, m minus 3. I got all of the denominators are the same now. It's all right with you guys if I just go ahead and mark those out instead of writing them in the next step, because they will be the same. So that means we've got m plus 3 times m minus 3 minus 2m times m plus 3 equals 1 times m minus 3. I don't really have to write that 1 there. So we will multiply these together. So this will give us m squared. We'll get a minus 3 and a plus 3, which is 0. That goes away. And then we get a minus 9. So m squared minus 9 there. And then we just have to distribute that negative 2m. So we'll get negative 2m squared minus 6m equals m minus 3. It will not, because that negative is going to get distributed here, and that was a plus sign. Yeah. And it is really easy to mess that up. In fact, it's like the #1 mistake that people would probably make on this, because that negative right there has to go with the 2m whenever you distribute it. And especially if you go ahead and distribute, like if you do 2 steps in one, you're really likely to miss it because it's right down here. Because putting minus signs there alone will cause several students to miss it usually on those. So be really careful if you see minus. All right, so if we combine like terms here, we're going to have negative m squared minus 6m minus 9 equals m minus 3. And that's a quadratic. We're going to move everything to one side. So I've got negative m squared minus 7m minus 6 equals 0. In general, it's not a good idea to try to factor or use quadratic formula if you can help it. Whenever your m squared is negative, it's just easier to do if it's positive. So how could I get rid of that negative right there? Multiply by a -1. Or I could think of it like moving everything over to the other side, however you want to think about, divide by -1. Basically, it's just going to change the sign of everything. So m squared plus 7m plus 6 is going to equal 0. And that makes it easier to factor. So you'll get m plus 6, m plus 1, which will give you the answers of -6 and -1. Is it okay for both of those to be answers? Are they going to give you zeros in the denominator? They are not. Only 3 and -3 would be the excluded values, so these are fine. Most of the time they are fine, but you will run into a problem on occasion where you get 3 as the answer and it ends up being an excluded value, so you have to throw that one out. Okay, questions on that one? All right, here's another one. How about you guys try that one on your own? check with your neighbor, see what they're getting, see where they're at.
I think you're okay. I think you're doing everything right up to here. And maybe that should, right here, this is a negative, that's gonna stay right there. This should be an E plus 5, which will make that a positive, right there. That's the, I think that's on the side. Yeah. Yeah.
Okay, that's what I got wrong.
All right. Here's what I have. It marched through those answers there because my screen doesn't work like it should sometimes, but you should get a positive 4 and a negative 3. Look at what you've got. See if it's the same fixative. And there's a chance you may have done like things slightly different. More or less have to do the same steps, but you may move stuff to a different side or something.
It seems right.
I think it seems right, but I can't remember off the top of my head for sure.
Wait.
All right, questions on this one? Did you have mine? All right. Yes. It is fine for you to do like I've done and just kind of get rid of it right here. It would be preferred for you to multiply, like when you multiply by this d minus 1, to do it on top and bottom. If you only do the top, I can live with it as long as everything else you do after that is correct. But because I'm going to assume you know that you were really multiplying both there. But to be mathematically correct, it needs to be on top and bottom. Otherwise, you've done something you really can't do. If you can make it all the way to the right answer at the end, then I'm usually not too nitpicky on how you show your work for that. Okay, questions? All right, let's do this next one. This next one looks difficult, but it's really not all that, like what looks more difficult about it is really not all that difficult. There is one thing that makes this problem right here difficult. And in fact, Gabby worked ahead. I want to see if she got this right. What makes this problem difficult is this right here. That is what most students mess up when they do this problem. So when you see a minus like that, you want to be careful. Wait, that's not right. So the denominators here, you got k squared plus 5k plus 6, and you got k plus 3 over here. But k squared plus 5k plus 6 factors into k plus 3, k plus 2. So if we factor this right here for those denominators, then our least common denominator can just be k plus 3 times k plus 2. It would also be possible to do this problem where we used k squared plus 5k plus 6 and k plus 3 as our common denominator. But sometimes, I'm not sure if it would on that problem, but sometimes it may cause you to have like a k to the third power. We don't know how to solve cubics unless you go back to doing like synthetic division and p's and k's and stuff that Coach Wood or Mr. Brown or I guess Ms. Martin, I guess all three, you guys have had all three of those, taught you how to do. We're not going to get into that. So if you see that you're getting like a k to the third power, you probably could have done something differently to make that problem easier. So all I need for this one is to put a k plus 2 over here with this last term. And I said that negative is the reason that most people are going to miss this problem. And that is because whenever you get rid of your denominator, you are going to write 3 minus the whole numerator here, k minus 6, and that'll equal k plus 2. If you do not put that k minus 6 in parentheses where you then distribute that negative, you're going to miss the problem. And it's really easy to overlook that because a lot of people will just put the negative with that k and not distribute. So you'll get 3 minus k plus 6 equals k plus 2, which is 9 minus k equals k plus 2. We'll add the k. 9 equals 2k plus 2. Subtract the 2. 7 equals 2k divided by 2. So 7 halves equals k. Gabby, had you not distributed the negative?
I did in my head, but I didn't on the paper. Because I wrote it down in parentheses, and then I erased parentheses, like, oh, this is a negative, and I'm fine with it. I didn't actually spell that.
Yeah.
So I almost got it.
Yeah. In fact, a lot of times, like, I've switched to giving this on, if I give partial credit on these, a problem like that with a minus sign, so many of you guys are going to do it, that I go ahead and work out the problem both ways so that I know if you got negative 5 halves, that's what you did. That was your mistake. Take off 2 points, move on. Because it's a very common error. And it's one of those things that I can warn you about, but unless you're very careful, you're still going to do it later sometimes. All right, questions on that one? We have one more to do, and then we get a little bit of time to work. So, I've got x minus 3. I got 3 minus x. I've got this one I'm going to factor into x minus 3 times x plus 2. Now, it would be really nice if this 3 minus x was x minus 3. Because if it was, then my common denominator could be my least common denominator could just be x minus 3 times x plus 2, which will make this easier. It is possible to do this problem where our common denominator is x minus 3 times x plus 2 times 3 minus x, where we got 3 things in our common denominator. However, if we do that for this problem, it's going to give us something that's x to the third power. It's going to make it much more difficult to solve the equation than if we just do what I'm about to show you. Okay, so if you find that all you need to do here is switch the sides of the equal sign, or switch the sides of the expression. You need to just switch the order, right? You got 2 options for dealing with this. You can do one thing that I showed you guys yesterday where we factor out a -1. But the thing I prefer to do here is to multiply this on top and bottom by -1. Because if I do that, that means if I distribute this, that makes this -3 and a positive x, which is just x minus 3, right? And it's okay to do that because I've multiplied top and bottom by -1. So I'm going to rewrite this here like that. So x minus 3 plus will be a -5 over x minus 3 equals 9 over x minus 3 x plus 2. So if you have one of those terms that you need to flip around, if you multiply by a -1 on top and bottom, it will flip it for you. And then your least common denominator can just be x minus 3 times x plus 2, which means we would need to multiply by x plus 2 for that first term. Also x plus 2 for that second term. And nothing for the last term. All right, questions so far? Okay, now our denominators match. I'm going to mark them out. I'm going to distribute this. I'm going to get 2x squared plus 4x minus 5x minus 10 equals 9. So that is going to be 2x squared minus x minus 10 equals 9. I will subtract 9 from both sides. So I've got 2x squared minus x minus 19 equals 0. And second factor. The only thing you multiply together to get 19 and 1. 19 is 19 and 1. But you do have the 2 there, but I don't think it's going to work, is it? Because if I put the 19 here, it's not going to work. And if I switch them, it'd be 19 and 2. Yeah, this is not going to factor. So if it doesn't factor, what can we do? Quadratic formula, or complete the square, but for this one, you're going to get fractions with completing the square. I would not do it. So we're going to have x equals negative b, which is going to be positive 1, plus or minus square root b squared minus 4ac all over 2a. So we are going to get 1 plus or minus. Right here, we're going to get calculator. 153 over 4. 153 breakdown. 9 goes into it. 9 times 17. So we're going to have x equals 1 plus or minus 3 root 17 over 4. And that will not reduce any further. So it's a 4 right there. I'm going to write the answer up here because I ran out of room. 1 plus or minus 3 root 17 over 4. That is not going to equal 3 or negative 2, so it's clearly going to be okay. It's really 2 answers because you would do 1 plus 3 root 17 over 4 to get one answer, and you do 1 minus 3 root 17 over 4 to get the other. If you needed decimal answers.
It's either 4 root 17 over 4 or 2 root 17 over 4.
No, because you cannot add the 1 and the 3 there, because that 1 does not have a square root of 17 with it. So you would just leave it like this for that. If you got something where you didn't have the root, where it was whole numbers, so if you got 1 plus or minus 3 over 7, you would want to do that. You would want to do 4 over 7 and negative 2 over 7 as your answers. But with that root, it can't be combined. So
now, like you do 3 root 17 and then add the 1.
right. So like the only way you would be able to get sort of like a decimal approximation for that is to put it into your calculator. You do 1 plus 3 root 17 and then hit enter and then divide by 4. That'll give you one of the answers. And then you'll do 1 minus 3 root 17 divided by 4 to get the other. If you need decimal answers for that, I'm going to ask for the answer to be in exact form, so you'll just leave it like it is here. I think everything you're going to see today on Delta Math is going to factor where you will get a whole number answer. You may see some of these. I think the worksheet we're going to do tomorrow or Monday is going to have some of these on it. And is the quiz on paper? If the quiz is still the quiz I give on paper, I know it's got, but I can't remember if it's on paper or not anymore. So, your assignment is going to be on Delta Math, and it is rational equations number 1. The assignment is going to give everybody the same questions for tonight's assignment. So normally Delta Math is one that gives you different questions each time, and you got to get them right. So if you miss some of these, you're going to miss them, and it's not going to give you more problems to do. So in a way, it's good because it means that you just have like these 10 questions, and that's all it's going to, even if you miss every one of them, it's all it's going to give to you, although we might be a little alarmed if you do miss all of these. So if you will, please work these out on paper and hold on to that paper for me, because we will all have the same questions, so we'll go back and look at them so we can see like where you messed up on those. So for this assignment, they're all the same. You might only make a 60 out of 100 for this. You may just make like a 60%, but as long as you have completed it, you will get credit for it, because it doesn't let you go back, and it may give you like the first retry. Like if you miss it, it'll let you try it again, but if you miss it that second time, it's just going to count it wrong and move on like on that, because it's giving you set questions. As long as it is complete and I see some work for it, then you are good on that. You don't have to do every single problem. So I was hoping we'd have some time, but it's about time to go. So.